Today we're going to be talking about the metric system as it relates to distance and displacement. In science, we use the metric system. We don't use the imperial system, we don't use feet, we don't use pounds. We use the metric system, meters, centimeters, liters, units like that. So let's go ahead and we're going to write that down. In science, we use the metric system. Now the metric system is also called the international system. So it's also called the international system, or the SI system, System International, because over in Europe, sometimes they like to play a little bit of word games and do things backwards, but that's all right. So metric system, international system, SI, sometimes you hear SI units, System International or metric units. That's all it is. It all means the metric system. All right, so from here, what is a meter? So let's talk about what a meter actually is. Now I have a meter stick right here. And the question is, what's actually longer, a meter stick or a yardstick? It turns out a meter stick is actually a little bit longer. So how many inches are in a yard? 36 inches. So if I actually turn this meter stick over, it turns out, because this side actually has inches on it, it turns out it goes up to a little over 39 and a half. So there's a little over 39 and a half inches in a meter. So a meter stick is definitely longer than a yardstick. All right. All right, let's go ahead and talk about distance versus displacement, because we're going to be using those terms a lot in physics class. So distance, that's a term you're probably familiar with. So let's start there. What is distance? Well, distance is the total length traveled. It's the total length traveled. So let's just kind of work this out. I'm going to come over here, and I'm going to start here, and I'm going to walk 3 meters. So how much distance did I travel? What was my total length traveled? 3 meters. Let's go ahead and do this again, a little bit differently this time. I'm going to start here, and I'm going to walk again 3 meters. I'm going to stop, turn around, and I'm going to walk 3 meters back to where I started. So now, what was my distance? What was my total length traveled? 3 meters in one direction, 3 meters back, 6 meters. That's my distance, 6 meters. All right, let's go ahead and contrast that with displacement. Now, displacement is how far you are, when I say you are, I mean any object. So how far you are from where you started. How far are you from where you started? That's displacement. So let's go ahead and do our little demonstration again. I'm going to stand over here, and I'm going to walk 3 meters in this direction and stop. So what's my displacement? 3 meters. Same as when I walked for the distance. So in this case, distance, displacement, same. Now let's go ahead and do this again. I'm going to start here. I'm going to walk 3 meters, stop, turn around, and I'm going to walk 3 meters back to where I started. So now, what is my displacement? How far am I from where I started? 0. So in this case, my displacement is 0, because I'm back to where I started. However, my distance is actually 6. right? Distance is total length traveled. I traveled 3 meters in one direction, 3 meters back. So their definitions are a little bit different. Sometimes the numbers work out to be the same if you're just going in the same direction, and sometimes the numbers work out to be a little bit different because they mean different things, but sometimes, again, the numbers just, depending on the situation, work out to be the same, right? This is what we're going to use most of the time in physics class, displacement. So there's two differences between distance and displacement. We just talked about the first difference. They have a different definition, and sometimes you'll actually get a different number. There's also, and that number, by the way, that number is called a magnitude. A magnitude. So both of these quantities, distance is a quantity, displacement is a quantity, both of these have a magnitude. Magnitude is simply the size of the number or the number. So 3 meters would be a magnitude. 6 meters would be a magnitude. Now, in addition to that, displacement also has a direction. A direction. And oftentimes, you know, we can indicate that direction by writing right or left or north, south, east, west. We can even use degrees. There's lots of different ways to indicate direction. So we could use, 10 degrees from the horizontal, 75 degrees from the horizontal, and then you could even get into radians too. There are lots of different ways you could indicate direction. For the most part, we'll be using right, left, north, south, east, west, and sometimes we'll be using degrees. All right, so those are the major differences between distance and displacement. Distance only has a magnitude. So sometimes a quantity, like distance, if it only has a magnitude, we call that a scalar quantity. So if a quantity only has magnitude, it's referred to as a scalar quantity. If a quantity, like displacement, has both magnitude and direction, then it's going to be referred to as a vector quantity. So any quantity that has magnitude and direction, force is a vector quantity. It's got magnitude and direction. Acceleration is a vector quantity. It's got magnitude and direction. Velocity is a vector quantity. It's got magnitude and direction. Right? So we'll talk a little bit more about this later. Now let's go ahead. How would I actually express a displacement? Oftentimes I'll write it like this. I'm going to use the abbreviation X for displacement. It's got different abbreviations, but I'll use X. And I might write X equals 3 meters north. All right, so what are the parts of this? So X is the quantity. In this case, the specific quantity is displacement. Three represents the magnitude. Some people might say, 3 meters is also part of the magnitude. Meters, M, is a unit. And units, as we're going to find out, are pretty important. You got to tell me, what is the unit there? Are we talking about 3 kilometers, 3 centimeters, 3 meters, 3 miles? All right, that's why it's important to put the unit. It's also important to put units for other reasons, because units can cancel out and they can actually help us solve problems, especially more complex problems. Finally, this last word right here, north, that's the direction. That's the direction. So when I write this on the board, now you kind of know the parts of what I'm talking about. If I'm referring to the quantity, that comes before the number. So in this case, the quantity is displacement. Distance is also a quantity. The magnitude is going to be 3 meters, or 3. The unit is meters in this case, and the direction happens to be north. So that's the difference between distance and displacement.